Classical RAG is excellent for conversation, but when dealing with structured numerical data, a single hallucinator number by LLM can compromise your entire analysis. Today, I'm walking you through a repository I've been working on that pairs the reasoning power of Anthropic's Agent Skills with a dual engine architecture. Vector search for semantic context and Oxigraph for a structured RDF knowledge graph. For the technical breakdown, I'm handing the mic over to our AI narrator, ae-Carolyn, to lead the live demo.
Today, we're building an agentic chatbot using an RDF knowledge graph based on the Federal Reserve's Monetary Policy Report. We're implementing Anthropic Agent Skills alongside Chroma DB for vector storage and Oxigraph for an RDF store to handle structured figures. The data comes directly from the Fed's publicly available reports. The high-level design features a Claude agent that manages tool logic and streams API outputs to the chat interface. The agent control loop orchestrates the interaction between the API, tools, and databases. I've also built specific agent skills, vector skills for semantic search and graph skills for querying the knowledge graph. By combining these, we get the best of both worlds: semantic search for context and native graph queries for precise data. So here is a list of sample questions I'm going to try out in the next section. Let's start with our first question. What agent skills do you have? I'm switching between models here, but keep in mind that Sonnet 4.6 is 3 times the price of Haiku 4.5. For simple queries like this, the advanced model isn't that necessary. As you can see from the toolkit, we have skills for semantic text search and chart data browsing, plus a graph skill that uses SPARQL. The agent explains it well. It performs semantic searches through unstructured text and uses the graph for data lookups, ultimately merging the outputs from both aspects. Now for our second question, summarize the 2025 monetary policy in terms of Treasury holdings. Since Sonnet 4.6 is pricey, I've switched back to Haiku to save costs on this straightforward query. You'll notice that for a question like this, the agent decided not to trigger graph skill at all. After a single iteration of vector search, we get a concise, on-point summary of the Fed's Treasury holdings and balance sheet. The response is backed by a citation. You can click to see that this specific chunk was extracted from the June 2026 Monetary Policy Report. Next question, what is the time series for the non-fuel import price index over the past 10 years? You'll notice the agent first triggers a semantic search, followed by the graph lookup and querying skills. These tools are invoked across several iterations as the agent's control loop determines the necessary depth. Here is the response. Because we requested a time series, the agent returns precise numerical data yielded by the graph skills, tasks that standard semantic search often struggles with. We also get brief, cited observations. I've included a custom script to optionally render a line plot whenever the agent detects time series data. Since these figures are retrieved deterministically from the knowledge graph's linked series, the risk of hallucination is eliminated. Every data point is mapped directly to its source. Last question. Provide the unemployment rate projections and a summary from the Monetary Policy Report. As you can see, the agent triggers a wide array of tools. It's worth noting that you might occasionally see a tool call fail. This isn't a bug, but a natural part of the agentic process. When an error occurs, the agent analyzes the failure, realizes its mistake, and generates a corrected tool call in the next turn. This self-correction loop ensures the agent persistently pursues the most accurate data until it can provide a reliable answer. Because this is a complex query, you'll notice more tool calls and a longer processing time. Now here is the result. I need to switch to the light theme for better visibility of the transparent charts. Since the latest Fed monetary report was published in June 2025, the projections reflect that period. We have projection tables for 2026 and 2027, followed by some statistics over a 70% confidence interval. You'll also see images rendered directly from the Fed's website. The links to the sophisticated graphs were ingested during the RAG process and are now referenced in context. The response then includes an analysis of uncertainty and risk, alongside a narrative summary from the semantic search tool, supported by more charts. Finally, again, we have the automatically drawn time series for reference, all backed by deterministic, reliable sources. You might be wondering what it actually means for time series data to be embedded and linked within an RDF knowledge graph. To demonstrate, let's take the sample query from our previous agent tool call, searching for time series associated with unemployment, and limit it to 20 results for a manageable visualization. Here are our 20 nodes, a network of associated unemployment time series. You can see how they are linked, ranging from national yearly rates to specific breakdowns by race and ethnicity, such as the unemployment rate for Black, Hispanic, and Asian workers. Let's pick a specific node, unemployment rate for Asian. When we click this, we see its IRI, Internationalized Resource Identifier. Think of an IRI as a unique permanent URL for a specific data object in the RDF knowledge graph. It ensures that every time the agent references Asian unemployment, it points to this exact singular data entity. Here is the time series for Asian unemployment pulled from Figure 11 of the source report. This illustrates the workflow in terms of structured data. The agent uses the lookup tool to identify relevant series, which then provides the necessary IRIs for the graph querying tool to construct a precise SPARQL query. I hope this provides a clear look under the hood of how RDF enhances Agentic RAG, and this wraps up the demo. Thanks for watching.
For simplicity, I'm using Chroma DB for local vector search, while leveraging RDF to ensure strict data consistency and interoperability. However, these same graph RAG principles apply just as effectively to labeled property graphs like Neo4j. So I just want to mention that beyond simple figure retrieval, the true power of graph RAG actually lies in its ability to map complex relationships, which is a huge evolution over just a classical RAG. I hope this demo showed you the power of combining Anthropic's agents with structured graph stores. Thanks for watching. I hope you enjoy it. I'll see you in the next one.